Good evening, everyone. I hope you were able to enjoy your Easter holidays a little bit, and it's nice to see a few of you back attending Jack's workshop tonight. And welcome back to those who attended his talk last week. Tonight, Jack concludes his talk on climate change by showing us how to use the WWF Footprint Calculator, and he will help you to analyze the results as well. Many of you may know Jack from his previous talk last week on how CO2 emissions affect us in Switzerland. During that talk, he pointed out some interesting facts talking about ethics and leading by example. And he raised the important question, do we prepare or react to the future? Jack is part of the Zurich chapter and has a background in mechanical engineering. He has held many talks before, and this is his second talk on the WWF Footprint Calculator. Correct me if I'm wrong, Jack. So we also hope that this talk will inspire you and others for change, one small step at a time. So Jack, you have the floor.
Thanks for the presentation. I've actually given this a couple of times, a little more than just twice. The typical climate change talk is such a downer that there was a real interest on, okay, so what can we do, to help change things? And so that's where this came from. And this is specific around Switzerland. So actually this particular model, there's a number of the WWF models out there, and this one is specific to Switzerland. So the goal is we have all these existing systems that we live under. And what can we do now? We can make an immediate difference, and that's part of that. It also shows what systems the corporations and governments kind of control, and longer term, it doesn't tell us how to change the systems, but helps identify what the systems are. And it gets back to, we talked last week about, well, what's the actual goal? Because everybody talks about a reduction, but the actual goal is 0 tons per person, which is just about impossible. So if we can get down into the 2 tons per person range, and then we can offset those, and we'll actually go through the calculator a couple times side by side, which will give us an indication of if we have one person that is really concerned and trying hard, and one person who's less concerned. And we can see some of the differences on that. So it's not just about greenhouse gas emissions, it's also about our environmental impact. And a lot of times, and we went over this last week, that if you focus on just one part of a whole system problem, you may not make much of a difference. And in some cases, you could even make things a little bit worse on a bigger perspective. So this is kind of a common one. You go into the store and you look for your food and go, okay, I want bio, and that's great, but it's coming from Canada or coming from China or someplace. And well, how does that compare to non-bio that's local? And then it gets to the system of, why can't I buy local bio, not in plastic, or in a plastic that's recycled? And so that's a system that it points out, but it doesn't help us to solve. So this is not a systems presentation. It really is around the footprint, but we really need to think about things from a systems perspective. And one of the things that we can, or one of the things that came up was a couple of years ago, bought some plants for the garden. They're plastic. I do not remember if they are recyclable or not. About 3% of all petroleum and natural gas is used in plastics. And what would normally happen is, if it's a good plastic, it gets recycled. And if it's not, it gets tossed and gets burnt. And it turns out that these were biodegradable. I said, oh, okay. But if you'll notice, it actually looks a lot like plastic. So a lot of the biodegradable pots are a pressed fiber that's coated in wax. Wax is a petroleum-based product. 2 years later, so I put them in the compost pile in 2020, they look like this. I haven't looked yet this year, but I figured they've got at least another year before they start to really decompose. And then the question becomes, do I really want the wax to decompose in the compost? And this is a linear process. We start off at the beginning, we work our way through, and we have some end product that is either burned, potentially recycled if it's made out of a plastic that's recycled here, or we throw it into the compost. But we have the same or more raw materials. We have the same manufacturing, the same shipping. So it's not a real change. It's the same system, just a substitution of material. And the question is, why was the pot biodegradable? What problem are you trying to solve? And so I did a little bit more research on pots. And this is just a picture of a biodegradable pot. They're coated, like I said, they're coated with wax. So a lot of them can be used for up to 5 years. It might degrade in another 2 to 3 years, maybe less if it goes into an industrial compost. One group was making, and I'm not going to go through a bunch of these. One group was making pots out of the pineapple skins. There was a pineapple orchard, and they said, let's take all the residue and make pots out of that. And a big difference is the walls on these are a centimeter thick. That's what they had to do in order to get them to hold together. People are pretty much aware of peat pots, just a different type. And there's a lot of places where these guys all make sense. But again, what problem are you solving? And these are just some ideas that people had that you can do at home, where you take, whether, you can read that. I would question using grapefruit or orange skins as a pot because they're fairly acidic. One of the things that came up in this was actually a whole article on the idea of let's make our food packaging edible. And I rather question that. If you look at an apple, we eat the package on the apple. We don't eat the package on a banana or an orange, but I'm not sure we really want the packages to protect the food from handling and various other things. I'm not sure that buys us anything at all. So an alternative is, let's make these plastic pots, but let's make them 25, 50% stronger from material that is definitely recyclable. And let's put a deposit on it. You get a pot at the store, you put a one franken deposit on it, you use it, take it out, put it into something else, you take them back, you get your deposit, and you have this. And so now we've started this kind of circular economy thing, which is great. And at some point, they will break apart. And if you made it out of a material that's absolutely recyclable, you send it back to the manufacturer, and you have a circular economy or a circular process instead of a linear process. And the advantages are, I just kind of use the same materials. And I only have to manufacture maybe once every, 5 years, something like that, maybe even 10. And so I get a real reduction in materials, electricity, shipping, all the things that we're trying to do. So the product is basically the same, but the process or the systems process is very different. So if you have a question so far, put it in. I'm going to take a second here and pull up I'm going to stop sharing and pull up the footprint calculator. So we have two of the calculators side by side, and we'll take the one on the left and we'll say, okay, this is a very concerned person, vegan, all of that. And we'll take the one on the right and say this person is more maybe traditional sort of thing. So as you go through the calculator, we'll go through it, you can click on the little information here and you can get an idea of everything that's going on, which is kind of cool. So person's very concerned. It's almost impossible based on where we are to get fruits and vegetables only in season and only local. So we'll go about 3/4. Over here, maybe a little, who really like to buy strawberries in the winter, or blueberries or blackberries or any of the others, right? And you can see in the difference here. So if you go up here, you can see what your tonnage is for each individual one, and you can see how that changes. So the dairy is a function of what is one serving. They give you the serving amount for milk, yogurt, and cheese. This person is, we said, a vegan. So we're here. Let's get rid of that. There we go. And so if you're not eating cheese, the thing is you're eating some substitute, you're eating something with calories in it. And so that's why they give you some tonnage. This other person, we live in Switzerland, we have cheese every day and we have cream in our coffee. So we're going to go to here. Okay. Eggs. The eggs are one egg is viewed as one serving. So when we're talking about how this is, if you have, let's say you don't normally eat eggs, but you have Vea or something, and maybe there's 2 eggs in there. So you've got 2 eggs on a week. But this person, again, they're a vegan. So we're good. There's a person over, well, you know, I like eggs and we have various other things in the food. We'll go out here. So and what you'll notice is it makes a difference, but it's not, you know, eggs are not a huge footprint contributor. Meat, on the other hand, are a vegan here. So over here, let's see, we're going to go in the order of 4 to 6 times a week, about every day, whether we, whether that's for lunch, dinner, whatever it is. And again, you can see if we're, you know, I don't know too many people that eat it 2 to 3 times a day, but we'll go to 4 to 6 times a week. Staple foods we eat, doesn't really matter. And so a lot of this, I'm not going to go through the information on it, but these are just basically, you've got potatoes, cereals, bread, whatever it is that we would normally eat. Fair trade. So we're going to say this person tries, but while it would be great to be exclusive, that's just about impossible. I don't know that I've seen everything as a fair trade product or organic in the stores. Most things you run into a cost issue, and so there's some trade-off, but we'll go with 3/4 on that one. This one, not too worried about it. Maybe a little bit. So about 1/4 of the things. But again, it makes a difference, but it's not, that's not a huge contributor to the problem. One comment would be is we have a number of these. And so even if they are small, like in the 1/10 of a ton, when you start adding up 10 or 15 of them, then it starts to add up and you make a difference. We never throw food out here from time to time. Not a little bit bigger difference. This person doesn't have a car. This person has one, and we're going to pick, so they're a mixed user, and we, you know, they're going to say about here. So they drive, but they also take the train. So, and you can get an idea if you're, one of the problems is once you've bought the car or motorcycle, you know, that's a large footprint in and of itself. And so we haven't quite doubled these guys, but we're going to go about there. And here's where we run into it. It's going to change a little bit because this one has a car. So we'll go through and do this. We're going to go with just normal. We have maybe a hybrid, something like that. If they have electric, an advantage in Switzerland, most of our electricity comes from hydro nuclear, so it's relatively clean, right? So there's not much change, oddly enough. I'm not sure what happened here. There we go. So if you use the biogas or the electric, you really starts to change your footprint. You know, one of the things that has come up is I'd love to get, some people have said I'd love to get an electric car, but in my apartment, there's no place for me to charge it. So they're kind of stuck with what sort of car they can buy. How much fuel? We'll just kind of go, and I don't know. In the chats, you guys have any feeling for one of this? Right, so that's 0. 4.5, okay. We'll go with that one. Thank you. That works. How many kilometers per week do you travel by public transport? So this is probably a realistic number for someone who doesn't have a car. They might even be a little bit higher. And hang on one second. Yep. Maybe we go up. Oops. There we go. We go up here for someone who doesn't have a car because they're taking it more. And we'll go down maybe to like here for someone who, sorry. There we go. "5 years travel by plane." This guy not flying at all. This one, over the past 5 years, how many hours per year did you travel? Well, if you travel, let's say you travel to the US or something, round trip, you're at 20 hours. So your flight time is, it's about 8. So you're say 16 hours if you're right on the coast in the US. So, and then you have a couple other flights, so maybe you can get by with this one. So you're at 3.5 tons as opposed to 0. And you can look at some of this. If you're I'll say local, if you're within Europe, every trip is still in the order of 1/3 of a ton. And some people go, why is it so high? And a lot of it has to do with, and you would see this if you use other flight calculators, a lot of it has to do with where the emissions take place. So the typical, I shouldn't say typical, a lot of calculators will double the amount of emissions when they're flight because they're up in the atmosphere already, and others will use less. So when sometimes if you're looking at a flight and go, I'm going to offset my flight, you wonder why there's such a difference, and that's one of the reasons. But we're going to go up here. I think that's pretty average. And on a cruise, same thing. Not on a cruise here, and maybe over the last 5 years. So if you did 1 week per 5 years, that puts you down into one of these ranges. Maybe we'll pick the 4 to 6. We're at 1/2 ton. And I don't know, one of the problems that the ships has is when they come into dock, a lot of places where they are, there's no place for them to generate electricity. And so they're still running their diesel motors. And that's one of the things that's really changed in a lot of the commercial ports is for the cargo ships as well as for cruise ships is they can actually plug in so they can turn the engines off. Just stating something, not saying that. And a lot of times I will make a comment, it's more stating a fact than trying to pass judgment. That's not what we're trying to do here. So primary house, this is actually a good one to look at. So you might know what your heating is. I actually haven't turned the heat on in 6 years. The 2 apartments have been really well insulated and just don't need to. But it goes down, and if we look at, and we'll look at these in a minute, you know, they're saying that wood is pretty good. The problem is the smoke and exhaust gases. You need a filter system. Then you're going to have to dispose of the filter. So you have another environmental issue with your system. Think of it as system again. And so for a large number of people, the most environmentally friendly way is with a heat pump. And if you look at, we'll just pick a couple here. So if we have oil heat, this is over the course of just a winter, you're at 1.5. District heat is a little bit better. Your heat pump is pretty reasonable. And then wood and solar is a little less. We actually have a heat pump. Sometimes I pick, and we can do that, I pick wood with solar simply because, like I said, I haven't turned the heat on in 6 years. So it seems, actually, you know what? So the reason, and I forgot about that, is to pick the heat pump is we had to manufacture the heat pump. So if it were to get cold for a long enough time where we needed the heat, we may never reach that point, but I had to manufacture a heat pump. So there is some footprint associated with having the heat pump itself. Does your house meet standard? So this is more around how well insulated it is. So if you have really well insulated, you're at negative. There's not a lot of difference. So a lot of the ones that were built after 2009 simply have enough insulation on the outside that it's about as the same as in energy. And from one stand, you might even, from an insulation standpoint, it can be the same. You use more energy because the Energy P homes need to run a ventilator in order to make sure you have enough fresh air. So we're just going to pick, for this one, we're just going to pick an average house. I have no problems doing the same. We could pick a little older one if you want, just more by coincidence. It isn't, sometimes you find the apartment, but this is one of those things, if you go to move, for whatever reason, your job says you're somewhere else, you go to move, how well insulated is the apartment? How big is it, right? So we're here, apartment size keeps going up. 2-bedroom apartment in the, I think it was the 60s, was about 50 quad meters for 2-person. Now it's, or even less, now it's larger. So we're gonna pick that. So I'm picking a larger apartment, but I'm also assuming in the next question, it's how many people live in there, and we're gonna go with 2 people. So if I wanted to pick it by myself, you can pick a smaller one, and you'll see this in a minute when we go to the next stage, but we're gonna pick just a little bit larger apartment. And then we have how many people. We'll pick the same for each one. 2 people. 2 people. And you can see if you cut that in half, then you're using a lot less heat per person. How warm? This one over here, it's well insulated. Don't need to worry about the heat too much. This is the same, but you know, and I know people, right? 21, that's just a little bit, we're gonna go a little bit more. And I know people that keep their apartments at 23. And this, how much this changes is really a function, not just of the temperature, but what is your heating system. So if you were to go back through this again and look at, oh, I had oil heat, you would have a much higher emissions level on the 23 degrees than you do when you have a heat pump or something along that line. What type of house? We're gonna pick an apartment for both. We're gonna rent. And if you look, we'll just check and see, and there's no, the answer helps to go further on some other questions. Hot water was the same, basically it's the same sort of heating source, and depending on the type of apartment you have, they use the same heating source for both. For both heating the apartment as well as for hot water. This one, I think we picked, whoops, the heat pump. This one, and I don't remember, I think we picked a heat pump also. But if you look at, so let's go, right, oil. So if you were to look at the difference, not only do you have the difference here, but when we used it as a heating system, because of the temperature, you would get more of an effect with a higher temperature. So if we look, so this is just the larger ones, right? So the freezers, washing machines. There is not a huge difference between these guys. It's a little bit worse here for the double A, but if we're A plus, we're pretty good. We can pick about the same for this one. Refrigerator, I would pick something along this line. Just, it seems to be installed in most of the newer apartments anyway, or when you rent them. That's the one with freezer on the bottom. If you get to a small one, it's the same. It doesn't change it much. I still have a similar size unit that I have to cool off. This starts to change because you're having multiple. Washing, right? So used to wash it pretty hot, a little bit cooler, and a lot cooler. It's not, you can wash it at cooler temperatures. It makes a difference, but it's not a big difference. So a lot of times we get hung up on the little things because we see them right in front of us that are on a daily basis, but it's some of the other topics that make a larger impact. For example, on this one, clothesline, sometimes, always in the dryer. So we'll go there. This one we'll do half and half. It's only a tenth of a ton, a hundredth of a ton different. Small appliances, they exist. Everybody has a phone, computer, various other things. So we get dinged with that for living in a industrialized country. Green energy. So I asked about this, and the definition of green energy, since most of the electricity in Switzerland is basically low to zero emissions. But green has to do with, if you're looking at hydraulic, is there a way for the fish to go around? Is it impacting? What other impacts does the source of electricity have? We'll go here and we'll see what the difference is. We don't use any, so that's minus a tenth, and we're at zero. We're just not worried about it over here. Supply and waste. We have drinking water, we have a public waste disposal, and all those things create emissions or a footprint. So, right, 20 a month. So you're at 240 a year for clothes, which if you go out and buy, if you say, well, I just want to hike some, you kind of spent your yearly budget on a pair of boots. So maybe that lasts you 2 to 3 years. You have other clothes. If you were to go to secondhand stores and buy, that drops the price. You're using, I don't want to say recycled, but clothes that have been used before. So you're in this range, right? If you're careful, I think you're somewhere in between these two. I think it would be very difficult to live with this, though it saves you a tenth of a ton. So we're gonna go here. I think this is, like I said, really I would like to see how that happens. We don't care over here. We're gonna spend, right? I need some new fashion stuff, whatever that is. And so we're gonna go up here, and I don't know if we go up to 125, see, it depends on shoes. I don't collect shoes, so that's not, I guess I need a little help here. Go with the 33, third of a ton. Leisure. So if you don't do much, you're at 50 a month. So this includes kind of everything. You know, are you not going out? You're not eating out. I'm not playing video games online. What are your hobbies? Do you go skiing? So it's a little bit difficult to do this. You can live, you know, you can obviously do this. The difference, well, that's about, yep, about a third of a ton. So that's fairly substantial. And we said this person was going to be super, I have one that's a little bit less strict, and I will show you the results. It's too difficult to do 3. It becomes harder to see. This one, on the other hand, we go out to the movies, we go out to eat, we go skiing, belong to a fitness center. There's a bunch of these things. So I think this is probably pretty easy to get up to this range, right? And if you look, if we were to almost double that, you're up there. And so they don't quite double the emissions, but we'll go there. Household appliances. So this is not, and furniture. You know, so is your couch up? You know, we've had it 5-6 years. It's time to get another one, or not. So it's interesting too. This can be a function of age. If you're, you know, if you're right, just entering your profession or just leaving home, you need to buy a lot of stuff. And so you can go to the secondhand store and get it. But if we look here, looking at estimated lifespan in months or larger, you want, or longer, you want 15 years for some of the appliances. It requires more energy, they're more expensive, but if they last for 15 to 20 years, then it's worth doing that. So I don't know if we can do that. Maybe we'll take it for this one. This one is also, this person's always finding something new that they want to buy. And so we're up to 1.5 tons here. That may be a lot to do that, 200 a month for that versus 125. We're at 1,000 a year. We'll do that one. We'll not go quite so much. This one, if you think about that, 50 a month, so you're 12 francs a week. So that's more of snacks. That's just kind of a takeaway. I was down, you know, I was somewhere, I didn't have anything with me to eat and I got hungry. And so I just picked up something to tide me over. This one, and I know people, so you eat lunch out every day. So 5 times 20, you're at 100. If you go out on the weekend or something, it's pretty easy to get up to here, right? So you go from there up to there. And something to think about is the buildings, and I think they talk about that here, the buildings need to exist. So as more people eat out, there's more of these buildings to exist. And so the footprint, I won't say grows, but in order to keep that going, there are more buildings and more emissions. And so as fewer people eat out, there's far less. And that's one of the reasons why the emission is so much lower. personal savings over here, we're going to do everything. And we really don't care too much. But if you look, there's there's 0.7 versus everything versus just a little, is it minus 0.02? I'm sorry, 0.07. So it makes a difference. I'm actually a little surprised it's that low of a difference. Right, so this is all the things that you just normally, it's soap, shampoo, any medical things, any sort of education, all of it. And I don't know if there's a bigger explanation here. So this is a systems aspect. Why are we buying 3 things of shampoo that are on sale that are totally wrapped in plastic? So we're here, right? We have to accept that one and this one. They have to build wherever we're living, so that just is fixed. Public services, so this is the same, right? We want to have police, we want hospitals, we want schools in the area, and all of that requires buildings and emissions and transportation and things along that line. That's just next. Next, we just want to go to the results for now. So here's the final result from our very concerned vegan to our average Swiss person. And there's substantial difference. We can then download a report, and I've added a report in the middle in which you have a concerned citizen. They own a car but don't drive much. They eat meat and dairy maybe 3 times a week, but they don't fly or take cruises. And what you see is our choices make a huge difference. So the emissions here are a little more than 4.5 tons, a little more than a planet, 6 tons, 1.4 planets, all the way up to 18.5 tons and 4.25 planets. And in the detailed analysis, we get to see a little bit more. And this is simply what we have for living in an industrialized country where we have running water, waste management, schools, hospitals, things like that. And you can see the difference between the vegan and the low meat, low dairy diet is basically 30%, with the typical Swiss diet having about 3 times that emissions. But the real problem comes in the mobile lifestyle. When we're flying 30 hours a year, taking a cruise once every 5 years, mainly using a car, we create 10 times more emissions than the concerned non-flyer, and about 30 times more emissions than the person only using mass transit. Housing simply shows some system problems, and as more of us let the owners know that we want our heating changed and the building insulated, then those systems start to change. And the last section is simply consumption of non-food. As we use, we shop at secondhand stores, we use platforms like Sharely, that simply allows us to reduce our impact. And so I would really encourage you to play around with the calculator and see how the different choices affect your footprint. So if you were to look up on how many tons of CO2 per hectare you can get if you were to replant forests, numbers kind of vary all over the place. And some of that is because rainforests grow faster than in a temperate forest, but there's either fewer trees or they don't last as long. So you have fewer tons per hectare. Then you have a temperate, these are forest numbers. You get far higher numbers if you're planting in a plantation. So you just have rows and rows and rows of trees, which is far less of a forest. But in either case, if we were to replant forests, we've cut down in the order of 250 million hectares since 1950. Other areas we've planted more, but this is the net forest loss. You'd end up with we could sequester at a forest rate, we could sequester some 10 billion tons. There's 8 billion people, so it's more than 1 1/3 tons per person. If you went and planted those, like I said, more of a plantation where you can get a lot more tons per hectare, you could probably get this up into, and I don't know about this number, I did not see that replicated in other places, but you could get this into the 2 to 3 ton rate. So that on top of changing additional systems that we have, we're in the range if we're really, really careful to get down to a net zero. And that's the end of the presentation. If you have any questions, ask.
And there is one question that came up. Fabian asks, how often is the calculator updated? Maybe Jack, you can.
Yeah, hang on. I want to say 2019 was when it was updated most recently. So they update it I would guess every couple of years. Some of it's based on the more data coming in on what are the emissions for dairy or other food aspects. And cars change also.
Maze was also saying there's country-specific calculators, yeah. I guess. Is that true? Yeah.
Yes, this one is specific to Switzerland. Yeah. So if you were to use one for and I have not done it, but if you were to use one for the US, they would calculate dairy differently because they're raised a bit differently. I know there's one for the UK, but.
Okay, all right. Take this opportunity to say thank you to the team who was working behind the scenes. It takes a lot of effort and a lot of work to organize an event like this. And we're all volunteers from all 3 chapters. So thank you again to Pia, to David, to Mel, and to Shannon for working in the background, and also to Jack for his talk once again. Thank you very much. So moving on to the next slide, just a few closing remarks before we leave. Please take a minute to check out us on social media. We're on Instagram, Facebook, and LinkedIn, and we have our YouTube channel as well, where this talk will be uploaded afterwards. And also for our upcoming events on the next slide. You can, with our social media, you can stay informed with our upcoming events and follow our social media campaigns. And as you see here on the slide, we have a few things coming up. One is Say Yes, is a CO2 campaign that will take place in May. It's an online event, as well as Panda Watching, Where Are We? That will be also online. And hopefully our next in-person event will be a cleanup day at the end of May that will be all around Switzerland, and all our chapters are organizing cleanups. So save the date for all these 3 events, and we will also be sending out links, or if you're interested in signing up, you can register on our meetup page as well. So have a good evening, everyone, and thank you very much.